All right, up and running here. I'm hoping I got the right worksheet. I'm gonna do problems 40 through 60. Everything's starting to look the same to me. I just wrote 4 tests. And let's say there's an awful lot of overlap from test to test, as you might imagine. So let's do some problems together. And when necessary, I'll try to generate a little conceptual understanding, perhaps. So at this stage of the game, we're using inverse operations. I hope you can follow. Add 4, 2, log base 4 is asking the question, what do I put on top of 4 to get what's inside the parentheses? Sort of. I'm not sure I want to say that exactly that way, but log base 5 of 25, for instance, is 2, and we can rewrite that as 5 squared equals 25. And that's a little simpler to understand. All right, it's the inverse. So we're gonna change this to, I guess I should show this. Log base 4 of 2x. We are going to use the same process here. Logarithmic form converts to exponential form. So therefore 2x equals 4 to the 2. 2x equals 16, x equals 8. You can always check your answers. So 2 times 8 is 16. What's the exponent you put on top of 4 to get 16? It's a 2. 2 minus 4, -2, move on. All right, I'm kind of trapped over here. You can see it a little better there. All right, so I'm going to do 2 values here. I'm going to do f of 12. And I think if you put 12 in here, 12 minus 12, 0. 15 through to 0 is 0. 0 times 0 times 0 times 0. 15 times is 0. So I can't draw that 15th dimension. No, not happening. But I also think that cancellation occurs when I get the 15th root of 7. Boom. So I want to make this 7. I think 19 gets that done. So I guess I didn't finish this first one. So f of 12 gets you 15. And f of 19, oh my Lord, get you cancellation. -3 plus 15 gets you 12. All right. 43 seems like deja vu redundancy. But let's see if we can just knock it out of the park with some inverse operations. So that's 8 divided by 4 is 2. 3 to the 2 is 9. Adding 5 is 14. Let's check our answer. 14 minus 5, 9. What's the exponent you put on top of 3 to get a 9? A 2. 4 times 2 is 8. 8 plus 8, 16. Move on. All right. I'm hoping that more than half the class now can knock this out of the park. And let's make the 1999 8 over here. Because that's a jump from 1 to 8 of 7. And this is a jump of 1 to 15. It's still y equals 1 here. 1 to 15, 14. So that's a 2 to 1 jump, the differentials. So 2. Well, let's move that dot. Of course, do I remember what I wrote here? No, I don't. That was stupid. Oh, God. 15. I remember the 15. 2000. I usually do 23. We'll go with it. Could be a new problem now. There's a jump of 14. That's a better graph, a 2 to 1 jump. So what do we have? We have y equals 1. Our first jump is 7. The next one is twice that. Or you could have written 14 over 7 and still gotten credit. Time, let's base this on time. So let's call this a population based on time. There you go, population based on time. And we're basing our first value off of 1999 and our second one off of 2023. So that was a mistake because I'm looking at the change, 24 units. There we go. Now I'm back on track. Let's see if we can picture what's going on here. Let's put 1999 here. Minus 1999 gets us 2 to the 0. 2 to the 0 is 1. 1 times 7. That 2 became a 1. 7 plus 1 is 8. And then we drop in the 2023. Minus 19.9 is 24. 24 divided by 24 is 1. 2 to the 1 is 2 times 7, 14 plus 1, 15. Okay, most of you have those down and can do those pretty darn quickly now. So here's the original question. So we got to get x squared. So we got x. Right now we got x squared minus 2x. We need x squared minus 8x. I need another -6. There it is. There's your minus 6x. But also we now have positive 12. And we got to get to 1. How do you get from 12 to 1? You got to go down 11. X minus 2. So if we did the first multiplication, x minus 2 times x minus 6, we're going to get x squared minus 8x plus 12. Let me hide this again. Okay, so hopefully x minus 2, x minus 6, you can see that. And then what happens to the x minus 2s? They cancel. Minus 11 gets us 1. Now, the remainder is minus 11. All right? The critical number is x equals 2. Because we could have put the minus 11 on the outside. We could have written this as x minus 6 minus 11 like that. And if I put in a 2, it cancels that, and I get negative 11 out, which means over here, the 2 has to get us a negative 11, or that's a mistake. 4 minus 12 plus 1. Oh, 16. Excuse me. Okay, 2. There we go. Minus 16 plus 5. Move on. Okay, now I didn't have a copy of what I wrote down for graphs, so this one's probably different than what's on your sheet. But let's see if we can knock this out of the park quickly. Let's start with y equals. Okay, so this is probably a new problem here. So what do I see for y values? I see 2003. Why don't I write it? I see that it changes, goes up 21 years. I can see a logarithm. I can see that my domain is x greater than 8, and I'll communicate that to the reader by writing x minus 8. You better pick numbers bigger than 8, or you're not getting anything out of this graph. Oh, what do you got? You got your second x here, which is 12. So let's put 12 in here. 12 minus 8 is 4. I don't know what log 4 is. Regardless of the base. I don't know what it is. Because I don't know the base. I suppose right now it's base 10, but we're just constructing this. So we don't have a base yet. If you don't have a base, then you better have only one log. 1. Doesn't matter what the base is. That gets you a 0. And 0 times anything, like the number 21 is 0. Oh, that gets me 2003. So I guess when I use this number, I want to create that. The only way I can turn a 4 into a 4 right now is divide by 4. Otherwise, I'm going to get all kinds of crazy numbers here. Okay, so that takes care of the x minus 8, takes care of the asymptote. We'll put a little check on the asymptote. 12 minus 8, 4 divided by 4 is 1. Log 1 is 0 times 21 is 0, 2003. My second x works. All I got to do is make a 20 come out as a 2024. I can make that happen. 20 minus 8, 12 divided by 4 is 3. And I want to get 2003 plus 21. I want to get that. So I better multiply by 1. Well, how do I make log base 3 the number 1? Make it a 3. So there's your equation. You might have to play that if you haven't figured out how to do this. A lot of you can do this very quickly now and easily. But if you can't, I suggest you play this one over again until you can. All right, roots. Again, I do not have your handout. I do not know what root I put down on that worksheet. So this could be a fresh new problem. All right, but it's still measuring from 5. 0 is up here. This graph does not equal it, so I know I'm going to have imaginary answers. How far do I have to travel? 7 units up. But I'm multiplying by -2, so I'm going to divide by 2. Now, really, up 7, right? Dividing by -2. That's why I'm putting I here. Okay. Now, what would this be in graphing form? So you can at least see the process. -2, 5 -7, x plus 5 squared minus 7. We want that to equal 0. So let me do that for you quickly up there with some inverse operations. You should be able to do those in your head now. All right, so -7 becomes what? +7. Multiplication by -2 becomes division by -2. Squaring becomes plus minus, square rooting, and the square root of a negative is an imaginary square root. That's why we have 7 halves. Takes care of that, takes care of that, takes care of that. Addition of 5 becomes subtraction of 5. Once you know what you're doing, pretty quick and easy. All righty, let's see if I can move this desk up here and tackle this problem. All right, a very quick look at this. Oh, was my marker? Yeah, been doing a lot of math today. I'm already starting to lose my computational skills, but I can tell you that isn't factorable. So you got a choice. Put it in graphing form, which is another way of saying complete the square. We're pretty good at that. We're pretty good. So I would suggest that's what you do with this problem. Or you got to do the quadratic formula, which we haven't practiced a lot because it's cumbersome. And most of the problems we've been working with can be handled more easily completing the square. So x plus 6 squared minus 36 minus 3 equals 0. I'm showing the completing the square process for this rectangle. That rectangle is x times x plus 12, right? And so what I've done is I've taken half of the units off there and moved them this direction. And when I do that, lo and behold, I get a square. Of course, that's not 12 anymore, it's 6. And the 6 I added there. Well, instead of drawing a square, I think I'm trying to show you the square symbolically. Okay, and if I multiply this out, I get x squared plus 12x plus 36. And I don't see the plus 36 up here in that rectangle. That's why that materialized. Piece of cake now if we're solving. Did I ask you to solve it? I don't know. Let me see. I assume so. All right, so what do we got? We got minus 39 on this side becomes positive. I'm going to do it in one line of work. Positive 39 on the other side. Squaring becomes plus minus square rooting. That takes care of that. Positive 6 becomes minus 6. And you should watch how that works here. Let's do it. I'll show you how it works. All right, so let's complete the square again for practice. So we've got x plus 6 squared minus 39. And now I'm going to drop that in, my answer in, minus 6 plus or minus the square root of 39. What happens to the 6's? Cancel. What happens to squaring? Positive or negative positive. What happens to squaring the square root of 39? You get 39, and 39 minus 39 is 0. Okay. We've been looking at logarithms the whole semester. What are we looking for in this particular log? The exponential activity on top of m cubed. That gets me what? M to the minus 20. So what's our answer? Our answer is minus 20 over 3. All right, so what's the 3? Cube root. You take the cube root of m cubed, you just get m. And if you raise that to the minus 20, that's what you get right here. So our answer was minus 20 over 3. So I lost myself in that problem. I'm not sure I gave a good explanation there. So let's see. So it was m to the 4 to the minus 5. And this is log m cubed. So right now we're cubing m. But we want m to the minus 20. So what do we have to do? We have to get rid of the cubing. And we have to bring in the exponent we want. So there's a little conceptual flavor for that. And that's the exponential activity. Again, m to the 3 to the x equals m to the minus 20. It's probably overkill. M to the 3x equals m to the minus 20. Hopefully you can see that answer now. Woo! Yeah, I've been doing too much math today. We've already done about what? 55 problem, 4 tests, 200. Yep, wrote about 300 problems downstairs. All right, so here's the original problem. We want to be able to just get our answer. So let's explain where it comes from. So x to the 16th is really x to the 16th divided by 1. I'm dividing by x to the minus 5, which is really division by 1 over x to the 5, right? X to the minus 5 could have been written this way. Let's move in this direction. When you divide by a fraction, you multiply by its reciprocal. So we have x to the 16th over 1 times the reciprocal of this, which is x to the 5 over 1, which is x to the 21. Right? I hope we can see that now that you have negatives. They can move into the other position. If you got a negative in the denominator, you can move to a positive in the numerator. So I'm hoping that you could just kind of see that. Right, now, what do we have for the m's? M to the minus 3 is 1 over m cubed. And I'm dividing by m to the minus 2, which is 1 over m squared. Okay. Same thing. 1 over m cubed gets multiplied by m squared over 1. And I can see that I have 1 more m in the denominator. Right? M cubed is m squared times m. So that becomes the number 1. 1 times 1 is 1 over m. There's your answer. So what do we have here? We have this. We can move the negatives. So that's x to the 16 times x to the 5. I can move m to the minus 2 into the numerator as 2, into the denominator as 3, and hope we can see that we're just counting factors. 21 x's, you know, x times 21 times. And we've got 1 extra factor in the denominator. All right, trying to explain these as we go along. 2 points for a graph here. Sketching this graph. I see an absolute value. I see a positive. I see a V shape up. I know I have to get 0 as a minimum. And that occurs when x is 3. And if I put a 3 in, I get 0 times 5 plus 9 is 9. And I like the y-intercepts. The y-intercept is the next value of 0. 0 is to the left of 3. If I put a 0 in, I get 5 times 6 plus 9, right? 0. Absolute value of negative 6 to 6, 39. And you do that. We should talk domain and range now. What's the domain? Domain's all reals. There's no restriction on numbers. Their distance from 0 on a number line. There's no restriction. There's no restriction on multiplication. There's no restriction on addition. So that's all reals. The range, however, that's another matter. There are no y values here, right? An x. Here, I'll just put an x ruler here, right? And that starts at 3. And I can move to the right and I can move to the left. Y's are shown with vertical rulers. And I can see that on this vertical ruler, I have a 9, nothing below it. I think my y's are greater than or equal to 9. And if you make the connection, then it's a 3-second question. That's how long it should take you to write that. That's what we're after. We're after you saying, oh, that's so easy. I'm not worried about that at all. All right. Sketch, I guess. I like to write it in this form. That's the one form that you don't see in the textbooks. Because I think that's in the form of a x minus h plus k, which can then be written as a x minus h squared plus k if we're looking at a cup-shaped graph, which can be written as a x minus h cubed plus m times x minus h plus k. You haven't studied that yet? Well, a few of you have, but not too many. But this continues the fourth and fifth and sixth and seventh degrees. I don't think they're very useful after the cubic, fourth degree. It's not really, well, who knows? Maybe there are some things to learn there. But I think this is more templative. Okay, so, but keep in mind that that's written, well, I should have moved it. Yeah, probably saw that mistake. Move the 6 to the other side and you have what's called point slope. Which means if you're going to graph it, you might as well pick a point and then use the slope. But I think this is point slope. It's no different. You've got a point, 5, 6. What are you doing? Going down. At what rate? Let's move this dot over a little bit. Down 3. Over 4. You got a good little graph there. And if you want to, get down 3 from 6, then you're at a y value of 3. If you want to go over 4 from 5, you're at 9. Nothing preventing you from labeling 2 points. And that shows the reader that you understand that calculation. Nothing more to it. We've been doing pretty well with naming 3 points, 5, 6, changed by 4, 9, 13, 17. We've been doing pretty well with that. Down 3, 3, 0, what? -3. Well, plot those points. You'll see them line up. That's why it's called equation of a line. All right. 54. Let's move this a little further from the board, but let's keep going. So 5x squared plus 40x minus 7. I like to start with minus 7 plus 40x plus 5x squared. So I like a y-axis, and I'm starting at minus 7. We'll put that as a dot. I'm going up at 40 to 1, pretty steep up, and it's cup shape up. If it's cup shape up, it's got to be drawn like that. Okay, so this is on the increasing side, so 0, -7. Okay, all we need is the vertex. We can see that 5 goes into 48, so it's going to be -4, but you take more time with it. Minus 40 over 2 times 5, right? -40 divided by 10, -4. You plug it in, minus 4 times 40 is minus 160. Shortcut is cut it in half. And then add the minus 7. I better do it on this. All right, so -4 squared, just to show 16 times 5 is 80. -4 times 40 minus 160 minus 7. 80 minus 6, that is half of it, right? 80 minus 160. So minus 87. And you're also, so if I gave you this graph and I didn't give you the equation, I'm asking you on the test to create it. So what would you do? I would hope you would say, oh, x minus 4 squared minus 87. And I would hope you would get from -87 to -7, you've gone up 80. -4 to 0 squared is 16, 4 squared. Well, there's your 5. And yes, you have to learn how to do this as well. So we might as well do it for more practice. That's 5 times x squared minus 8x plus 16 minus 87. That should get the job done. 5x squared, I think we started with that. Minus 40x. Ooh, I thought we had a positive. Good thing I'm doing it from a different perspective, right? I said -4 was important, but I wrote x minus 4. I should have wrote x plus 4. All right, so that takes care of that. Let's go do it again. It's important to know when you make a mistake. So x squared plus 8x plus 16. minus 87. Now we got it, 5x squared plus 40x, there it is. And 80 minus 87 plus 80 minus 87, we can see the minus 7. Okay, so that should be old hat 2. All right, so we got another population as a function of time. Maybe I'll write this as t. And over here, I've got somewhat the inverse, so I probably should say not population time t as a function of amount. So I'm going to put this as an A. That's a little different perspective. All right, so what do we have? We got a jump of 10, and we got a jump of 30, and that's on top of 2. Which means my y value is going to be 12, and my y value is going to be 32, if I pick the right numbers. When will I get a jump to 10? When I multiply it by 1. How do I turn a 3 into a 1? Exponentially. What has to be above that? 0. So I hope that's another chat about why you're picking 1540. It was a very good year. I remember some fellows from back then. We go and take some road trips. Yep. 500, 1940. Years changed by 500, so 1940 should be a very friendly number. That was a very good year. Yep. 1940 minus 1540 is 500. 500 divided by 500 is 1. Yep, there's your jump of 30 on top of 2. Exponential growth. Okay. Been doing those for the last 2.5 months. Some of you are just starting to look at it. Some of you can do that in under 10 seconds. So amounts. Logarithms are really about the inverse of exponential. Exponentials, for the most part, are time to amounts. So the logarithms take the amounts and tell you at what time you have them. All right, so my y, 1915. Well, I can get 1915 if I add 0. Is there a way of making log 3 equals 0? Oh yeah, make the parentheses 1. Okay, so that's possible. Is there a way of getting 1915 plus 60? Well, I guess I need that to be a 1. Is there a way of making log base 3 equal a 1? I think so. All right. So amounts, time to amounts, I guess if we're going to go amounts to time, amounts better be positive. Right? You know, if we got some radiation discharge from a power plant, there's something there. We start counting bacteria growth in a petri dish, and I don't think we're counting unless there's some bacteria in that petri dish. And we want to see how corn grows, you know, doubles in height every so often. I guess there's got to be corn in the cornfield. So I guess the parentheses of a log, right? The parentheses has to be greater than 0. The parentheses would be nice if it was a 1, because I know that. I don't care what the base is. Log 1 is a 0. 0 times anything is real easy. And I think if we have a logarithm where the base is the same as the number in the parentheses, I think we're creating the number 1, right? And if we have a 1 in here for a log, we're creating a 0. Real easy to multiply something by 0, real easy to multiply something by 1. All right, enough said. So what do I see? I see that's greater than 0 when my amounts are greater than 9. The inverse of growth looks like that because we've done 1,000 of them this term, I'm guessing, on the board. Maybe you individually have done about 50, I'm guessing, or some of you have skipped it. And so let me write this over here. I want the parentheses, a minus 9 over 7 to be greater than 0. I want a minus 9 over 7 to equal 1. I want a minus 9 over 7 to equal the base, which in this case is 3. So there's my first friendly number. This is bigger than 9, I'm positive. I've got something to work with. When does this equal 1? 7 times 1 is 7 plus 9 is 16. Okay, how far is it from 9 to 16? 7 units. Oh, that's a big clue there. And then I want this to be 21 plus 9, 30. That's going to be a very friendly number. How far is it from 9 to 30? Whoa, 21. 21 divided by 7 is 3. Must be a coincidence. Okay. So let's put the numbers in and see what happens. 16 minus 9. 7 divided by 7, 1. 19, 15 plus 60 log base 3 of 1. What's the exponent you put on 3 to get a 1? A 0. 0 times 60, 0. 19, 15. That looks good. And then let's try, oh God, where am I? Oh, plugging 30 in. Okay, so 30 minus 9 over 7. 21 divided by 7 is 3. What do you put on top of a 3 to get a 3? 1. 60 plus 1950. 1915 gets me, brain, keep working. 1975. I don't even remember if I gave you the original or if I had a graph here and I worked off it. I'm not even sure what I'm doing anymore. No. Okay, we had a discussion. Very good. All right, the range. I do remember seeing that. There was a question about range. Well, I got to jump to 20, I got to jump to 60, and it's on top of 7. I think all these y values here, bigger than that. Nothing else to be said. Range is a description of the y values on the graph. I can see all these y values, all those altitudes. Here's your y ruler. Here's 7. Never equals 7, but it gets real close. F of g of -2, so we got to do g of -2. Find that value, and then we'll put it into the f function. Minus 2 to the 4th is 16, right? Even number of negatives. Minus 14 is 2. And so now I got to do f of 2, which is what this means. F of 2 is 5 times 2 cubed minus 2, which is 5 times 8 minus 2, which is 40 minus 2. Answer 38. I ask you to memorize the square root of 3 over 2, actually the first week of school. Approximately 0.87, close enough. Right, and this distance comes from the isosceles triangle 1, 1, 1, which is going to become very familiar to you when you study trig. So I thought I'd plant a little seed. I'm going to drop a perpendicular. And that takes me from 0, 0 to 1/2. Root 3 over 2 is a height. So this is actually the coordinate 1/2 root 3 over 2. And that's a 60-degree angle, which you will learn about radian measurements. That's 180 degrees, which is also something to do with circumference equals 2 pi r. If I make the radius 1, then 180 degrees, planting a little seed here, is equivalent to pi. And if I divide that by 3 and divide that by 3, that's another way of saying a triangle that's got a 60-degree angle. It's coming your way. So what am I looking at? I'm looking at the Pythagorean relationship here. So what's the square area of a half? 1/4. What do you get when you square the square root of 3 over 2? What do you get when you square a over b? You get a squared over b squared, right? Because squaring means a over b times a over b. As we say in India, top times top, bottom times bottom. A squared over b squared. What's a squared? Square root of 3 times the square root of 3 is 3. 2 times 2 is 4. Okay, so 1/4 area, 3/4, 4/4, which is 1. And the square root of 1 is 1. So what's the distance between these 2 points? 1 unit. Okay, so what do we have? We have a fraction that needs some reducing. You can see it. The only way I know how to reduce things like 8/12 is to find the common factors. 8 is 4 times 2. Oh, excuse me, it's 4 times, 4 times 2, and 12 is 4 times 3. Oh, I guess I can cancel those 4s. I don't need to do that. So 8/12 is 2/3. Yeah. Multiplication undoes division. So I want to change these subtraction statements into multiplication statements. Well, what's common? 2x minus 8, I think a 2 is. X minus 4. What's common for 16 minus 4x? I think 4 is common. 4 times 4 minus x. Whoa, I think we better look at this. I wonder if that reduces. If it reduces, it's supposed to reduce for all numbers. So let me put a number in here. Put 9 in. 9 minus 4 over 4 minus 9. Let's put a 10 in. 10 minus 4 over 4 minus 10. Let's put an 11 in. 11 minus 4, 7. 4 minus 11, -7. I think you'd be right if you said that becomes -1. So that gives me -2/4, which I hope you write as -1/2. That's that problem. Then there's 40 through 60. And I need a coffee. I need something. Oh, old man. All right. See you in half an hour. I'll post this now.